In 1980, I was having lunch one day with my PhD supervisor, the well-known architect Buckminster Fuller, and I expressed to him my concern for wasting my life in school. He looked at me and said, "Find a problem no one else has solved and solve it." That really did change my life. My name is Nick Peckham, and I have been an architect for 40 years. I've noticed that my profession has never had much concern for Mother Earth. That strikes me as a very serious problem. As seen in the UN conference in Paris, we have the heads of hundreds of countries trying to figure out what we can do about global warming, which is caused by putting CO2 into the atmosphere. About half of that CO2 put into the atmosphere is caused by heating and cooling and lighting and operating buildings. If we can build more buildings like the one this film is about that produce more energy than they use, I think we could solve the CO2 problem right there. I've decided to design and build the greenest house on Earth for my wife Diane and myself. This house will produce more energy than it consumes and will serve as a model for future home construction. I don't pretend for a minute that it's going to be easy to change our ways, but I really see no alternative unless we want to give up life as we know it here on this planet. Today they are pouring the stem walls for the greenest house on Earth. Glad to have the house moving along. We got a good break in the weather here. It is October, and it's going to be 80 degrees today. So that's either good or that means global warming has arrived. I don't know which. Concrete continues to strengthen throughout its life. This is 4,000 PSI concrete, which is built to last. It will have an initial strength in a range of 3,500 PSI, but in the first 30 days or so, the strength will increase to 4,000 or even more. Concrete is one of the most energy-intensive products in any building. The whole science of concrete, or a larger field I call building science, is emerging even more right now because of people like me and others who are really trying to figure out how we can reduce the impact of the built environment on the natural environment. Buildings use approximately half the energy on Earth, 40% or more. If all buildings could be net positive like this one, just imagine what that would do to the world economy. Most houses that have a slab-on-grade construction, that is no basement, have a stem wall foundation so that the concrete slab and stem wall are one piece. The problem with this construction is that the cold or heat, but mostly cold from the outside, goes right through the concrete. Thermal bridging is one of the biggest heating and cooling problems in any building.
I mean, we're used to certain things. We build very big homes, don't get me wrong, but this is a lot different than anything I've ever built. Foam, this is interesting too. I've never done that before on a floor before you put the concrete down. I've never done that. This has been an experience too. 4 inch thick by 4 foot by 8 foot long.
You're gonna take an L out.
Take an L out.
Yep, that's what we want. After the house gets occupied and is lived in for a while, the slab becomes the same temperature as the house. Therefore, in order to change the temperature of the house, you have to change the temperature of the slab, which is a big job.
We just got done putting down the white 12 mil plastic around the whole inside of it with the 4-inch foam underneath of it. Then we have to go back around and put 4 5/8 foam on the inside of the perimeter all the way around it, and then seal it with caulk and tape, and then they will be pouring the concrete on Monday. And this is really high duty plastic, waterproof tape. This came with a lot of time. Nick Peckham, he's a very good architect.
I bet he could light a candle in this house when he's done and heat the whole thing. Well, that's the deal.
Hey, today we're pouring our concrete slab floor on our structure here.
Even though the house costs about $5 more a square foot than a similar high-end house with normal construction, the advantage of building the way we built is that the energy cost will be zero. The energy bill, which otherwise would have been $200 or $300 a month or more, will go away. We will recover this cost in a very short period of time and will continue to recover it throughout our lifetimes. Since the house will outlive us, we will recover it for years beyond that. Today there are 3 different crews here. One is from Thermocore of Missouri. They're bringing the SIPs, the structural insulated panels, and they're going to start putting them up over there in the kitchen area. Second is Schultz Crane, which is picking things up and putting it where they need to have it. And third is some carpenters from Glidewell who are doing whatever framing and attaching needs to be done. And it will probably take, at least half this week, maybe a little bit more, to get all the exterior walls up. That's all the panels.
All these little pieces you're gonna put in place?
See, this one right here is there.
Yeah.
And here's the kitchen window they didn't cut out. There's another window there. Breakfast window, dog window.
Cool.
These guys are organized.
I guess they have to be.
So,
I see they've got little holes to put that crane thing through. And then they must fill up the holes.
yeah, then they fill them
And
up.
they fill them up. Very clever. These people are very clever.
Here's the coat closet here.
Let's go all the way back to the 1960s. And back in my hippie days, we were always very interested in saving the planet. Ideologically, I still think that way. I like to look at it as not so much green building as it is energy efficient building. And the uniqueness of this panel system is that it uses polyurethane rather than EPS. The polyurethane is a 2-part mixture that we inject into the panel, so it's not a block foam, it's actually injected and it sets up inside the panel. So with our foam, it's a Class 1 fire rating, which virtually you cannot burn one of these panels. Well, you can't burn them. They keep their structural integrity until they're completely consumed.
Cool. This is me and my twin.
So we have a closed cell gasket that would stick right in here on the interior of this panel. Whenever you have these 2 panels together, you can see where that foam gasket actually helps seal up the system. And that's the big thing to have an energy efficiency. You can have a high R value on a panel or on a system or in any type of house, but if you can't stop the air movement in a house, then you're not really that energy efficient. So the air tightness makes a big difference on the energy efficiency. Now, having the solar panels, a great idea, however you want to heat and cool your home, but if you don't have an envelope that you can contain all that, heat and air inside, then it doesn't do any good. So the part that I like about the deep green that Nick is doing is that it actually is effective.
Hang on to the ridge. Bring the ridge to you.
Come to us about a foot.
Keep going.
Keep coming.
Bring that son of a bitch over there. Right there.
Having been in the construction business for over 35 years, and I've had the opportunity to build a lot of fine homes, but this is the first opportunity that I've had in my career to really exercise some of the techniques that make this home special. Over the years, we've always utilized good windows, good insulation factors, and things like that. But there have been numerous steps that we've taken along the way here, different products that we've used that really set this project aside from any other project I've worked on in my career. It's great that I've had the opportunity to work with Nick and kind of help him implement his designs and his vision for the home that he's going to live in the rest of his life.
Now all you want to do is zigzag, just take it all the way up through there.
This side of the whole thing.
We're probably going to need more material,
To be able to spread it, yeah.
Yeah.
More than that?
Yeah.
Yeah. We're going to make that all one color. We want this to be opaque, and that's it.
Today we're insulating our home here, our deep green net zero home. The liquid house wrap that we have installed on the house was a product that I've never used. It's being utilized a lot in commercial construction these days. We have a typical exterior wall detail, which is our SIPS panels, which are filled with foam. So for our ceiling insulation, we've created an 18-inch floor cavity up here using an 18-inch open web floor truss, and then we've applied a netting on the bottom of that, and then the blown cellulose fills up that 18-inch cavity there. The cellulose product is a recycled paper product that has been treated with a borax product to prevent infestation of bugs and mice. Has a little dry adhesive mixed in with it, and then it's moistened as they spray it in so that it stays in place. There's a small slit cut in the netting that we've installed on the bottom of our trusses. They feed the hose into the center point, and then he's able to activate the blower with his remote here to start feeding the blown insulation into the ceiling as we speak. There's a blower in the truck. There's two hoses, one that carries the product in, another one that vacuums up the spillage off the floor and sends it back to the truck to recycle it through on the next round. Why would people not choose to spend a little extra money to minimize their utility bills, to preserve the environment, use recycled products? Both Nick and I would hope that this home would help set the bar for some of the standards that will be used in Columbia over the next several years. I'm nearing the end of my career, but certainly hope that this gives us the opportunity to showcase this home and to convince a few other people that this is the way they ought to go with their construction techniques.
The Deep Greenhouse here in Columbia, Missouri for Nick Peckham. It's seeking LEED Platinum certification and it's seeking PHIUS Plus certification. They focus really tightly on energy. So the Deep Greenhouse is going to have the best of both. It could very well be the greenest house that I've ever worked on, if not the greenest house anyone has ever worked on, hopefully. That's the goal. So all building materials are going to allow heat to transfer differently through them. But within that same building material, we want to see if there's something different going on. Not a whole lot that looks thermally different. Like if it's thermally boring like that, that's what you want. You want it to all just look the same.
Well, what we're doing here today is we're starting our rough-in on the heat recovery ventilation system. This is the only Passive House Institute rated HRV system. The way this house is laid out and to run them at the highest efficiency, we decided to go with the Mitsubishi ductless heating cooling system. The United States is the only place that uses ductwork. Everywhere else in the world has been using mini splits for over 40 years. So we're just behind on the technology. What's important about this ventilation system, it was custom designed for this house. With this house being so tight, you have to control moisture, smells, VOCs. Zender took the blueprints and did all the design for us, so we know exactly how many tubes to run to each room for supply and exhaust. These are proprietary Zender 3-inch, it's called Comfo tube. Each of these pipes will deliver or remove 12 cubic feet per minute from the room. So here we are in our mechanical room. Right here is where the HRV is going to be mounted. It's going to mount in this area here. This is the actual Zender unit that hangs on the wall. It has the intake and exhaust filtration built in with MERV 7, so it'll remove any contaminants that'll be coming in from outside. These are proprietary Zender 6-inch supply and exhaust air. It's made from closed cell polystyrene. This is the 6-inch tube that removes all the air to the outside and brings the fresh air into the unit. So basically this system's gonna remove stale, dirty air, humid air out of the house. It's gonna bring in fresh air from outside. But instead of just dropping cold air in the house, this has an energy recovery core in it. So it uses the energy from the air inside to heat the incoming air to nearly the same temperature that it's exhausting, then redistributes it to the room. When we get all done, Zender will actually send their factory reps in. They'll actually measure and balance all the airflow to where the supply air is evenly distributed through the whole house, as well as the exhaust air. There's going to be 7 different zones through the house. So for instance, in this house, if he doesn't use these 2 back bedrooms, he can completely shut those systems off. So it's complete comfort control, as well as energy savings. So we're far and above and beyond a standard construction home on efficiencies.
One of the hats that I wear at the city is teaching building science to our partner tradesmen. What we're doing is we came on site to learn how to do blower door testing and how to use that blower door as a diagnostic tool to find out where air leaks and how efficient a house can be. So we're actually setting up the blower door here now to do an infiltration test to measure the amount of air that's leaking in and out of the house. So what we do is depressurize the house to 50 Pascal, and then we can actually measure the amount of air that goes through that fan, and then we can assume that that amount of air is leaking through the walls and the ceiling and the floor.
Turn that off and then turn it back on again just to reset everything. All right.
Under 200.
And a 0.36 at 50.
And the code is 3.
3, even, yeah.
So we're way exceeding the code.
That's impressive.
I'm kind of curious now, the door that they were going in and out, let's go ahead and open that entire door and try to run another test. All right. Go in and out.
3,500, so it's still going to be less than, I bet, 30, or right at or less than 30% total leakage. You can live in this house with one whole door open.
And still be better than any other house in the city.
Right.
Yeah, that's
crazy.
One of the other things they're doing here today is they're installing a state-of-the-art ventilation system, because you can get a house so tight that it's not good for the house or good for humans in it. So it's a way of building the house tight and then ventilate it right. This is not the norm. We hope that someday it gets to the norm. But you can do it in a cost-effective way. This is above and beyond, very energy efficient. On top of the assets of the house and the construction and the insulation, I follow that through to the high-efficiency heating and cooling systems, and then the solar panels on top of it. It should be close to zero, net zero, if not beyond.
Nick and I have known each other forever, and Nick told me, I'm going to come look at flooring for my house, Dave. I want you to show me the greenest products that you can show me. That's something that I can use to help tell the story of what I'm doing with this house. The hardwood was a little more challenging because he has a couple of dogs and he wanted a wood product that the dogs wouldn't mess up. The hardwood floor is a very unique product. They, for practical purposes, put it in an oven and super dry it, which opens all the pores in the wood. And then under heat and pressure, they fill those pores with an acrylic resin. So I literally have now a floor that has no pores in it, so it doesn't absorb moisture, but also it's much, much harder. It's about 300 times harder, frankly, than a piece of oak, just regular, because all the open voids in that wood are full of plastic in essence. And just to give you an idea of durability, I would not recommend you do this to your floor at home because you'll mess it up. But you see the black mark? That's actually, I don't know if you can see that, but that's where I just wore the ridges off the edge of the quarter. I didn't hurt the wood, and it just cleans right off. That's the metal in the quarter. Did not hurt the finish of the wood at all. The wood's virtually indestructible. In Nick's office, he wanted something that was going to be a little more quiet. We chose a cork floor. This is cork, if you don't know, is natural. It's the bark of a cork tree, primarily grows in Portugal and Spain. The back is also cork. Cork will not support mold or mildew, and it also doesn't change dimensionally if it gets wet. So if water comes up through the slab, in the case of this house, it's really not going to hurt the floor. So literally it's a very resilient floor that should last a lifetime. In this home, even what we would traditionally call ceramic tile is green. It's actually a porcelain tile. The tile itself has 17% pre-consumer recycled products in it, has 5% post-consumer recycled products in it. As a matter of fact, all these floors are completely recyclable. But truly today, there's a significant push to making more environmentally friendly products that are affordable and easy to care for. And this house, frankly, is the epitome of Nick. Everything he's done here is to be as earth-friendly, consume as little energy, water, etc., 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 as he possibly can.
Once a house is complete and it's all sealed up, because our insulation and our building practices are so much better, you have all of these gases that are trapped in the house. As the products cure, so to speak, they off-gas all of this stuff. So if you're living in a brand new house and you haven't taken these products into consideration, you're living there breathing in formaldehyde and other gases on a daily basis until your house can emit it all out. Are you having any problems?
None that I haven't solved.
Okay. All right, good deal.
Yeah, thanks.
My name is Stephanie Hall. I'm with Mark Hall Cabinetry. My husband and I started our cabinet manufacturing business about 21 years ago. So we've been doing this for quite some time, and at this project we have supplied all the cabinetry and casework, and we will supply the countertops as well. We're using Pure Bond hardwood plywood. It's made by Columbia Forest Products, and it uses a soy-based adhesive instead of a formaldehyde-based adhesive. So it eliminates the formaldehyde off-gassing, which is typical in a traditional plywood, as the glue between layers. And then finally, the finish coats, or what you see that makes it all pretty on the outside, is a waterborne finish. It emits low VOCs, so it's healthier in the end because there's no off-gassing in the house as well. We build all of our cabinets right here in Columbia, so we're not shipping stuff across the country. We're keeping all of our products local, so our carbon footprint is smaller than it would be if we were shipping cabinets from China over to put in the house. There's a lot of little things that a homeowner or home builder can do that really impacts our carbon footprint greatly, and it doesn't necessarily have to be a great cost. It's cool to see it all come together and really make an impact.
The green movement, if you will, in the country is designed around keeping the carbon footprint smaller, using less carbon and emitting less carbon dioxide into the air. The interior of the house and the way the house is designed and all the elements that Nick has put into it to make it a greenhouse has a huge amount of savings in different areas. And what we do complements that. We're doing primarily the landscape. We're doing the fencing, we're doing the seating, the sodding, the rock boulders. We're also building a geodesic dome patio to put his geodesic dome on. It's a circular patio, and it's going to have pavers that are concentric rings to accent the shape of the dome. We've dug out and shot the grade and got the dirt out, and then we're going to be putting a weed barrier fabric down and coating that with 3/8 clean gravel to compact. And then we're going to compact the gravel and set our grades so the slopes from the center to the edges will slightly slope to shed water. The water runoff is important for a lot of reasons. One, it doesn't filter well into the streams if you get mud into the streams. So if your water and erosion control is in place, it can save a lot of topsoil from migrating off of your property under the construction process, because when there's bare dirt and you get a huge rain, a lot of your topsoil will go down and filter into the stream beds and mess up that habitat. So, you know, water filtering, erosion control methods around the property, the edges of the property, to keep the silt escaping your property until you can get it firmly established with some kind of cover, whether it be mulch or lawn or plantings. Nick's got a nice euonymus coloratus bigleaf winter creeper under his Osage orange tree out front here. It does well in the shade and you don't have to mow it. Ground cover beds are nice because they absorb a lot of water and they cover a lot of area. And once they're established, there's not as much maintenance on a ground cover bed. You're not mowing every week. You're not using fossil fuels to mow because you've got a natural ground cover there that snakes and critters like to live in. It helps the environment.
From the beginning, part of the house plan was to include photovoltaic or PV electrical generation, which is why the roof is sloped at 10 and 12 or perpendicular to the average angle of the sun here in this part of the world. We had selected a metal roof, standing seam metal roof, which is 25% recycled steel. But we selected it not only because of its recycled content, but because it'll last for a long, long time. It also has standing seams to which you can use some fairly standard aluminum clamps to secure the photovoltaic panels to the roof.
If you know anything about Nick, you know that he walks the talk for sustainability in green building. You have to start off a trend with having somebody like that bold innovator. So somebody who thinks that they're going to try to do it, and they do it. And so then you kind of see like, okay, well, what do they do to do that? And how feasible is it for other people to do? The way that City of Columbia, that we're lucky, is that we have a municipal electric utility. So our electric utility does give rebates for people to go solar for their house.
If you install a 10 kilowatt system like we did, it's possible to get the rebate from the city of $5,125, which took a $30,000 system down to a $25,000 system. In addition, the federal government gives you a 30% rebate for this throughout the rest of 2017. No telling what will happen to that law in the future, but that's the way it is right now. So in January of 2020 and on through the rest of the century for the life of this building, there will be no energy bills, so that you're actually making money and you're not adding any energy burden to the world that we're living in.
We just actually looked at his meter, and he has produced to the grid 7,631 kilowatt hours, and he has used 6,554 kilowatt hours.
When I got the first utility bill, I was a happy camper because it was minus $179. We're producing more energy than we're using, which is really great. We expected to see a net zero energy use in the house, but we were very pleasantly surprised to see that it's net positive.
Net positive houses they're pretty unique, especially for a city the size of Columbia, in a state like Missouri, where you don't have a lot of renewable energy on our grids in the central US. But Nick Peckham's house is definitely above the curve. This was no surprise that he would build the greenest house on earth. It's no surprise either that he would open up his house to people to see it. It's no surprise that he would try to encourage other people to do the same thing at their house. Now that said, you know, There's always that question of like, what's feasible for the average homeowner? Somebody who doesn't necessarily have Nick's expertise. So it's possible when you have architects and engineers and the local tradesmen that helped construct his house, now that they have that knowledge, that they can then try to replicate it in other homes. Education is going to play a key role in making this possible for others.
Even though this is just one family in one town here in America, I think that if everybody did it, we'd be a lot better off.